everyone, and welcome back to Atman Unlimited. Today we're going to continue our series on tool offsets and work offsets. This is going to be method 2 that we're going to use for setting our tool offsets. So let's fire up the machine and get to it. We're back at our machine again. Let's show the second way to do tool offsets. In our previous video we talked about the first way to do offsets, where we don't use the tool offset table and we just use the work offset coordinates. We talked a little bit about the advantages of that, in that it's simple, it's easy to understand, and it's cheap to do. But we also talked about some of the disadvantages of having to re-offset our zero of our z-axis every time we swap our tools out. We also talked about how that we lose our datum anytime that we change our work holding by setting our work height off of a vise. The second method, we're going to utilize the tool offset table. Inside every CNC controller, along with the work offsets, which are your G54s, your G55s, your G56s, there are also tool length offsets. To set a tool length offset, that's what the H number is. For every tool, you'll have an H number in the tool offset table. Most people, for tool 1, they'll use H1. For tool 2, they'll use H2. That makes it pretty easy. They understand that tool 1 is offset 1, tool 2 is offset 2. In that offset table will be a number that will then be added or subtracted from the Z height. After you apply the H number, you then need to apply G code 43 or 44. To utilize that, we have to set up our tool offset table correctly so that when we do an H designation of which tool we have, and we do a G43 to apply offset compensation, our Z will be at the right height depending on the tool tip. So we need to decide how we are going to define what that height is. The easiest way to do it in method 2 is to use a reference that's in the machine that never moves relative to the Z. And that's the table. The table will always be in the machine, and the height between the spindle and the table for this machine will always be identical. It should never change. The only time it will change is if we do some serious maintenance to the machine, and then you're going to have to redo all your tool offsets anyway. So to set our tool offset, we're going to do the exact same thing that we did before, except instead of setting the Z offset based on our part or our vise, we're going to set it right down on the table. So we typically will jog our tool down to the table, and we'll follow the same setting methods that we did last time. Then what we're going to do is we're going to write down the number that our Z-axis is at the table, and that number will be our tool offset. Z0 on this machine is at the tool changer height up here, so the numbers will always be negative for my tool offsets the way that using this method. The less negative the number, the longer the tool. What this does is this allows you to set all your tool offsets ahead of time, so while you're running your part, you don't have to keep resetting your Z. And because we set it off the table, we can then make a part straight off the table using toe clamps. We can make a part in the vise using the vise. We can make any part we want, and we never have to readjust our tool offsets unless we take the tool out of the tool holder and reinstall it. It will save us a lot of time in our machining process using this method. But then you'll ask yourself, well, if I set the tool length offset so that 0 is the table, that's not very good because I don't want my 0 to be the table. In our other example, we wanted our 0 to be the top of this vice jaw. We can still do that. Utilizing our fixture offset just the same way we did before, we'll use our edge finder to find the corner X and Y of the vise. But rather than jogging the tool down to the vise and measuring it the way we did before, what we need is we need an indicator, and we need to measure the height from the table to the top of the vise. So now, instead of having a negative Z value in your work offset, you're going to have a positive Z value to lift the 0 up off the table to the height that your part wants to be at. It requires a little more G code to use this method. We need to designate our height offset number, our H number, and we need to apply our G43, and then we need to do another additional measurement for the Z offset for the G54 value. But it's going to save us a lot of time in the long run because we don't have to keep resetting our tool offsets for our tools. So that's method 2. I feel method 2 is probably the best method for the home machine shop to use if you have one machine, because we can still use the same low-cost methods to set our offsets. We can still achieve really good accuracies with these low-cost methods. And since we only have one machine, we don't have to worry about tool offsets being able to carry from the different machines. In the next video, we're going to talk about method number 3. And method number 3 will be used if you have multiple machines in your shop. It's more of a professional method to use. In comparison with method 1 in the previous video, you can see that method 2 lends itself to much greater efficiency. We can measure the tool lengths of all of our tools ahead of time before we go to run a part, and then as our program runs, we don't have to keep resetting the Z height every time we change a tool. But keep in mind that this requires us to have tool holders that will keep the Z reference every time that we take the tool out of the spindle and put it back into the spindle. That's where the tool holders come in. If you have an R8 machine, again, remember, you can get tool holders for R8 machines to be able to perform similar operations to this. Just because you don't have a tool changer doesn't mean that you shouldn't consider using this method of tool offset length and work offset, because it can yield the same speed increase even with a machine without a tool changer. Our next video, method 3, will also work off of the concepts from method 2. We're just going to start using external equipment rather than measuring the tool lengths in the machine. Thanks for watching, and we'll see you in video 3.